So here's a new question. What I'd like you to do is to find the slope of the line that has the following equation. And so let's make the equation negative 2x plus 5y equals 40. So there's an example of an equation that I'm claiming is an equation for a line. And your problem is to tell me what is the slope of that line. How would you like to approach this problem? Where do we need to end up on this diagram? What is the question asking us to find? It's asking us to find a slope. So ultimately, we need to end up right here. We need to find out what is the slope of this line. So that is our finish line. What's our starting line? What kind of information are we given in this problem? We're not given 2 points like we were in the previous example. We're not given a graph. I didn't give you a picture here. We're not given a slope-intercept form of an equation because we don't have the y by itself on one side. Instead, we have x and y together on one side of this equation. So where we're starting is we're starting over here with an equation for this line in standard form. So how do we go from this starting point to that ending point? So what do you think? According to the way that I've drawn this diagram, what would you think that our first step should be? Brittany? Yeah, why would I do that? What am I ultimately trying to accomplish by doing that? Yes, because what I'm trying to do is I'm trying to discover the slope-intercept equation for this line. Right? We don't know it, but we can find it. And we can find it by solving the equation for y. If we can get y by itself on one side of the equation, then what's on the other side of the equation will necessarily fit the mx plus b template. So Brittany is saying, let's get the y by itself, and the first step toward doing that is to add the 2x to both sides. So that what I'll end up with is 5y equals 40 plus 2x. Okay, and then what happens? Trying to get the y by itself, what's our next step? Want to get that y alone? Yeah, Jamie? Divide by 5. Here's a place to be careful, right? When you divide the right-hand side by 5, both of its terms have to be divided by 5. So don't just divide selectively, divide the whole quantity. So 40 divided by 5 gives me 8, and then 2x divided by 5, I'm going to write that as 2/5 x. So now I've got y by itself. And so my question is, what does that tell me? I'm going to move that over here just to get some space. So we have the y by itself. Y equals 8 plus 2/5 x. How do I match that up with the slope-intercept equation of this line? In other words, I guess what I'm asking is, how do I get the slope and the y-intercept out of the equation that we discovered? What is the slope of the equation of the line that has the equation y equals 8 plus 2/5 x? Brittany says it's 2/5. Do we have any agreement or disagreement out there? So tell me why the slope is 2/5. Because if I look at this equation, I'm going to say y equals mx plus b, but the 8 looks like it's coming first in the equation. So why is the slope not 8? There we go. What's most important about the slope in the slope-intercept equation is not which term comes first, but which coefficient is attached to the x. Right? The coefficient that's attached to the x is what plays the role of m, the slope. So it doesn't matter that my 2/5 x is coming second. The fact that the 2/5 is connected to the x is what makes it the slope. So if the question is, find the slope of the line whose equation is negative 2x plus 5y equals 40, the answer is that the slope is 2/5. What role does 8 play in this equation? If the slope is 2/5, what does that make the 8? It's the y-intercept. It's the coefficient of the constant. It's the one that's just out there by itself, y-intercept. And so the last thing that we can do with this is I'm going to take that information, the slope and the y-intercept, and let's use that information to quickly sketch a graph of this line. And that's where we'll finish this whole circle of ideas for today. So I'm just going to put up some graph paper. And now the question is to graph the line whose slope is 2/5 and whose y-intercept is 8. How would I do that? If that's the information I have about this line, how do I graph that line given that information? And here's my suggestion. Start with the y-intercept if you're trying to sketch a graph. If I know the y-intercept is 8, that means I know that the point 0.8 must be on this graph. So I'm going to start there. And now, from that point, I want to use the slope to find another point. So here's where we have to remember what a slope represents. If I know that the slope of this line is 2/5, how do I find another point starting from my point 0.8? What do you think?
Don't you go like down to an over?
Yeah, exactly. So what I'm going to do is think about what slope represents. Remember that a slope is just what we get when we divide the difference in y values, y2 minus y1, by the difference in x values, x2 minus x1. Sometimes, by the way, the difference in y values is called a rise. What's the vertical difference between these 2 points? The difference in x values is called a run, the difference in horizontal coordinates. So I can interpret the numerator and the denominator of this fraction to tell me what to do. For example, if I want to run 5, because that's a positive number, that means I'm going to go 5 steps to the right, starting from my point 0, 8. So starting from 0.8, I'm just going to go 5 steps to the right. 1, 2, 3, 4, 5, plus 5. And so that's going to take me over to here-ish. And then what about the 2 in the numerator? How do I interpret that 2? What's that telling me? Two is positive, but which direction am I going to move here if I have a 2 in my numerator? We know it's going to be a vertical direction because it's a difference in y values, and we know it's up because it's a positive number. So in addition to moving 5 to the right, I'm also going to move 2 up, and that will give me my next point, plus 2. So my next point is this point right here. If we wanted coordinates for it, we could add 5 to our x and 2 to our y to get 5, 10. And then all I have to do is connect the dots. Drive that down into place, and then we're done.